Yes, students, in last period we have checked about the measurement of different physical quantities. Okay, student, all physical properties are quantitative in nature. That is, their measurement are given with some particular quantities. These quantities consist two part. One of the part is called number and the another part is called unit. Like if I say the length of this pen is 7.5 centimeter, isn't it? That is what the quantitative measurement. Here the 7.5 is a number while the centimeter is a unit. So what is unit? Unit is the standard reference of the measurement. Getting? Student, from ancient time we are using different type of units for different type of physical quantities. Okay, like we are saying centimeter, we are saying meter, we are saying kilometer, picometer, angstrom. Okay, time is given by second, minute, hours, even light, even the distance is given by light year. Okay, mass is given by gram, kilogram. Okay, share in very earlier time. The length is measured by hands, yards, miles. So these are different type of units which we were using from ancient time. But the problem created when the worldwide, how to worldwide we measure or which unit should be applied in worldwide. Can we apply furlong even in USA or UK? Not possible, isn't it? Therefore, in 1960 in the France, one of the system worldwide adopted. This is called SI unit, which is called International System of Units, which can be applied worldwide. Okay, of different physical quantities. Student, some of the quantities are called basic or fundamental physical quantities. Fundamental quantities means which depends on only one measurement, which depends on only one measurement. Okay, like the length, we require only one dimension, only one measurement. Like the time, like the mass, it requires only one measurement. Okay, example, what? Mass. Okay, time. Okay, say length, etc. So these physical quantities require only one measurement. Therefore, these are called basic or fundamental physical quantities. Now, I am going to draw a table where I will give you the symbol of all physical quantities, their unit, and the symbol of the unit. Okay. So, students, we are having 7 basic physical quantities. Okay, 7 basic physical quantities. Like here, physical quantities. Okay, symbol. Okay, and what will be the SI unit? And what will be the symbol of SI unit? So the first property, this is called what? Length. Okay, and what is its symbol? Its symbol is L. Okay, what is its SI unit? Its SI unit is meter. I think you all know. And what is the symbol of meter? It is what? Small m. Similarly, the second one, it is given by mass. Okay, what is the symbol of mass? Denoted by m. Okay, What is its SI unit? This is called kilogram. Okay. And what is the symbol of kilogram? This is what? kg. We are denoted it by what? kg. Third one is time. Okay. And how do we are denoting the time? Denoted by a small t. What is its SI unit? This is given by second. And what is the symbol? It is what? S. Fourth one is electric current. Student, electric current is also one of the very important physical quantities which we are often used in chemistry and physics. Getting? Electric current is given by the symbol what? Capital I. Okay. And what is its SI unit? This is ampere. And what is the symbol of SI unit? This is capital A. Remember, capital A only, not A and 0. Otherwise, it will become angstrom. Okay. Fifth one is thermodynamic temperature. Thermodynamic temperature. In physics and chemistry, we are using what? Temperature. Which temperature? Thermodynamic temperature, which is denoted by now T. Okay, capital T. This is small t. This is what? Capital T. And this is given by the SI unit what? Kelvin. After the name of scientist what? Kelvin. Isn't it? And what is its symbol? Very simple. It is what? K. Next one is, again this is very important, amount of substance. Amount of substance. Okay, this is related to Avogadro. Amount of substance. This amount of substance is denoted by N. Okay, and what is this? SI unit is mole. In mole concept, we will study about the mole, that is Avogadro number. And its symbol is MOL only. SI unit is mole, but the symbol of SI unit mole is what? MOL. Okay. And the last one what? Seventh, luminous intensity. Luminous intensity. Okay. Luminous intensity. It is denoted by IV. IV. Okay. And what is this? This is candela. Candela. Okay. And its symbol is Cd. So student, these are what? Physical quantities. Which physical quantities? Basic physical quantities. These are called what? Basic physical quantities. Basic physical quantities means which depends only on one measurement. Okay. So 7 type of basic physical quantities are there, along with what? Their symbol, their SI unit, and the symbol of the SI unit. Student, along with, okay, there are many derived quantities. Okay. What is derived quantity? Physical quantities which, okay, are the resultant of 2 or more, okay, basic quantities. 2 or more basic physical quantities, or simply you can write what? Quantity. Now what? 2 or more basic quantities. Like, can you tell me what is density? What is this density? Density is what? Mass upon what? Volume. Mass upon volume. So here 2 things is there. What? Mass upon what? Volume. Isn't it? Volume, that is length. Volume, that is length. So here we can say mass. Mass is given by what? Kilogram. Here is the kilogram. Okay. And volume, this is what? Length cube. That is kilogram divided by meter cube. So the unit will become what? kg meter per cube. Isn't it? Like speed. What is this? Distance travel per unit time. Now distance travel, that is what? Say displacement or what? Length. Okay? Distance upon what? Unit time, per unit time. Now the unit of length is what? Meter, and for time it is what? Second, and it is inverse. So meter per second. This will be what? Speed. So these are called what? Derived quantity. Can you search some more derived quantities and their unit? So yes, okay. You search from the book and prepare in the notes. Student, actually the study of this SI unit and all this in this table is very important. When we will solve the numerical question, then you will see their applications. That means they will be used frequently. Therefore, you must have to learn all this very nicely. Yes, student. Now, the next one, different units of length. What is the SI unit of length? The SI unit of length is what? Simply meter, and is denoted by what? Small m. But besides of it, okay, some more denotions are there, like what we are saying, kilometer. This is what? 10 to power 3 meter. This is what? Kilometer. Okay. Micrometer. This is called 10 to power minus 6 meter, and this is denoted by what? Mu. It is denoted by what? Km, kilometer. That is 1 kilometer is equal to 10 to power 3 meter. Some more is there called nanometer. This is called 10 to power minus 9 meter and denoted by nm. Next one is angstrom. I told you earlier. Angstrom. Okay, this is what? 10 to power minus 10 meter denoted by a naught. Then one more is there, picometer. What is this? This is 10 to power minus 12 meter denoted by pm. Student, actually these units like picometer, angstrom, nanometer, micrometer, these are used when we are getting the length between two atoms or the radius of atom. It is very too much short. Therefore, these are given with minus power of 10. So, all these things you have to learn. Similarly, different units of temperature also there. Units of temperature. Okay, which are these? Like, what is the SI unit of temperature? This is what? Kelvin, and it is denoted by what? K. But besides of this, there is what? Degree Celsius. Denoted by what? Degree Celsius. And what? Fahrenheit. It is given by what? Degree Fahrenheit. So these are some units or scales of temperature. Okay. How can we convert? Conversion of different units of temperature. So there is actually what? Some relationship between it. Like Kelvin, temperature is equal to what? Given degree Celsius plus 273.15, or you can write it for simplicity, simply we are using what? 273. Okay, like example, what will be Kelvin temperature for 30 degrees Celsius. So how to solve this? Solve it. 30 degrees Celsius means place the value 30 plus 273. Okay, is equal to what? 303. This is a Kelvin. Student, in 9th class already you have studied about it. Now second one, conversion of degree Celsius and what? Degree Fahrenheit. Degree Celsius and degree Fahrenheit. Like question, convert 37 degrees Celsius into what? Degree Fahrenheit. So to convert it, like the relationship we have developed here, similarly we have to develop what? Relationship formula. Relationship formula between what? Between degree Celsius and degree Fahrenheit. So what is this? The formula is degree Celsius upon 5 is equal to F minus 32 in bracket upon what? 9. Or you can say what? 9 into degree Celsius is equal to 5 in bracket F minus 32. So using this relationship you can solve the question. Now the degree Celsius is what? 37 degrees Celsius. So the degree Celsius is 37. So now place the value. So it will become what? 9 into 37 is equal to 5 F minus 5 to ja 10, 5 3 ja 15 and 1 60. Okay, so 160. Now again solve it. 9 7 ja 63, 9 3 ja 27 and 6 3 33 is equal to 5 F minus 160. Isn't it? Now to find it you can write 5 F is equal to 333 plus 160 is equal to 3369 and 314. So you can get here F is equal to 493 divided by 5. Now the answer is 5 9 ja 45. Okay, remaining what? 4. 5 8 ja 40 and this is what? 6 degree Fahrenheit. This is the temperature of healthy man, 98.6 degree Fahrenheit. So in this way you can you can convert the degree Celsius into Fahrenheit Celsius. Like a question. Okay. I am writing here. Okay. Question. At what temperature degree Celsius and degree Fahrenheit will have same values? Same value. Okay, that means what? We have to find that temperature where the degree Celsius becomes equal to degree Fahrenheit. So to solve it, what to do? Very first, which formula you will use? What? 9 into degree Celsius is equal to 5F minus 160. Isn't it? Let degree Celsius is equal to X. Okay, and degree Fahrenheit is again, suppose we are considering it what? X. Now start placing value. 9 into X is equal to 5 into X. 5 into X minus 160. Or we can write 9X minus 5X is equal to minus 160. Or 4X is equal to minus 160. Or simply X is equal to minus 160 divided by 4. So that will be minus 40. So at minus 40 temperature, the degree Celsius and the degree Fahrenheit will have the same value. Getting? Yes, student, next one, and this is very important term. Actually, you can say that from here, your main chemistry started. Okay, till the 2-3 videos you have seen, all the things are quite familiar to you. But now the terms or the things or the concept which are I am going to introduce are new for you. Student, precision and accuracy. So what is this? Actually, if you see the meaning of these two terms, precision and accuracy, in the English dictionary, there will be actually no change. Nowadays days we are using, in place of accuracy, sometimes saying precision. In case of precision, sometimes we are saying accuracy. But in the science, that is physics and chemistry, okay, they have some differences which we have to check it. Student, in very early video I told you that the measurement of physical quantities have two parts. First part is number, second part is unit. The second part, unit, we have already explained. Now we are going to discuss next one, which is what? Precision and accuracy. Now what is the difference, or what are these two terms? Okay, so let's understand. Student, whenever we are given some experiment or some activity to perform it, like say, suppose we are taking the temperature of the room. Okay, so it is possible that there should be some error in the device. Therefore, what we are doing, we are checking the temperature at least 3 times. Suppose we are checking our own temperature, so only one time we are not checking it. We are performing it 2 to 3 times or 4 times, and then we are getting its average reading, and we are giving, this is our saying that this is our result, isn't it? Similarly, if you have to check the length of a pen, it is not necessary that the first time the student, that is the performer, can exactly measure the length. There is possibility of error. Therefore, what the student is doing, he or she is measuring it 3 to 4 times, and then taking its average reading, and then reporting the answer that this is the length of a pen. Because 1 time, 2 time or 3 time, there is chances of error. So our topic started from here. Like, let the standard, okay, length of a pencil is 7.5 centimeter. Okay, this is measured by scientists by following all sets of condition. That is, the apparatus used is very nice, okay, and the other factors, that is the skill of worker, means the performer, that is the student who is going to measure, okay, or the scientist, his skill is also very, very nice. In this standard condition, okay, the scientist measured the length of a pencil is 7.5 centimeter. So this is called what? Standard length or standard measurement. Okay, now three students are called to measure it, to measure the length of pencil, that is the same pencil which is earlier measured by the scientist. The students are A, B and C. Okay, and now A, B and C, and they are giving their individual measurements. individual measurements. That is different type of measurements. Like here, first measurement, second measurement and third measurement. Suppose student A, this is A, B and C. Student A is asked to measure and he is measuring, like first time he is saying this is 7.4 centimeter. Second time he got 7.5 and third time he got 7.6. That means what? In 3 time measurement, 3 different readings he got. So how will he report? He will report by what? Average measurement. Average measurement. Now what is average measurement? This is 7.4 plus 7.5 plus 7.6 whole divided by 3. So the answer is what? 7.5 centimeter. Isn't it? This is called what? Average measurement. Average measurement. Now student B is again measuring it 7.1 centimeter. Then he is saying next time 7.3 centimeter. And next time he is saying this is what? 7.5 centimeter. Now what will be the average measurement? 7.1 plus 7.3 plus 7.5 whole divided by 3. The answer is what? 7.3 centimeter. Okay. One more time, the student C is asked to measure it and he is measuring like 6.9, 7.4, okay, and 7.7. Now what? 6.9 plus 7.4 plus 7.7 divided by 3 is equal to 13, 20, 8 and 7, 15 and 7, 22 divided by 3 is equal to 37.3 approx. Isn't it? Now, with this experiment, we can define accuracy and precision. Accuracy. So, very first I am defining accuracy. If the average measurement, okay. Now average measurement are what? Which are obtained by different measurement, measurement is close to standard measurement, standard measurement. That means what? This is the average measurement and we have to compare this average measurement with the standard measurement given by the scientist, okay, known as accuracy. Are you getting? Like example, what we can say? Student what? B or A or C. 3 students are there. So what we can say? Student A is accurate. Student A is accurate. Now why? Because the average, okay, measurement, okay, given by A is close to what? Standard measurement. Close to standard measurement. That means he is accurate in his work. Means what? A. This one is what? Accurate. Are you getting? Now on the basis of it, we have to judge next one. accuracy. Okay, sorry, precision. Okay, if all different measurements, now what are different measurements? 1, 2 and 3. 1, 2 and 3, 1, 2 and 3. This is called what? Different measurements. So if we judge for any of the student, any one of the student, like suppose I am observing for student A, so his different measurement will be 7.4, 7.5 and 7.6. This is called what? Different measurement. So if all different measurements are close by what? By plus minus 0.1 up to this closeness. What? Plus minus 0.1. So if all different measurement are close by 0.1 to each other, okay, by one student is called precision. Okay, so student, now can you tell me which one is precise? Say A, B, okay, 7.4, 7.6, B is 7.1, 7.3, 7.5, and C is 6.9, 7.4 and 7.7. What we can say? Who is that is whose different measurements are close to each other. So again we can say what? Student A is precise in his work. Why is precise? Because the difference between the different measurement is only 0.1, which is applicable and acceptable. So we can say the student A is accurate as well as precise. Okay, this is called what? Precision. So now we can say student A is accurate plus what? Precise. What about student B? So student B and C are neither accurate nor precise. Okay, if you see some more example, you can change the number. Okay, like if I am changing the number like 7.1, 7.2, 7.3. Suppose I am dealing with this one. Say for D, one more. What? 7.1, 7.2 and 7.3. Now its average will come what? 7.3 again. So the average measurement is differ and very differ by standard measurement. So we can say student D is not accurate. But can we say that he is precise? So yes, student D is precise, in which means actually his different measurements are close to each other, and this closeness is of plus minus 0.1, which is what? Acceptable. Therefore we can say student D is precise but is not accurate. Are you getting? So this becomes the difference between accuracy and the precision.